In this module, we're going to read the temperature from a DS18B20. This is a waterproof probe sensor that's a little more versatile than your common ambient air sensor. You can use this to measure air or fluid temperature, which makes it great for a variety of projects. In this module, we're going to wire up a DS18B20. We're going to add one-wire support into our Linux system. We're going to find the device on a file system, and then we're going to use a pre-written Python script to read and display temperature, and we'll make some modifications to that. By the end of this module, you'll be a DS18B20 expert. As I mentioned before, the DS18B20 is a waterproof probe sensor. It's digital, which means there's less signal degradation over long lines. It's good from 55 to 125 degrees Celsius. Now, one of the neat things is it uses a unique serial number on each chip, which means you can run them in parallel and you can run multiple sensors off of the same pin. Now, you might recognize this GPIO diagram from our other modules. I'll show you how I've wired up the DS18B20. As you can see here, we have the red 3.3 volt wire connected to pin 1. Then I have the yellow VCC data wire connected to pin 7. And the black wire is connected at pin 6. Now I have a 4.7K resistor between the 3.3 volt and the VCC line that's acting as a pull-up resistor so we can keep our readings stable. Now here's the actual physical wiring of my Raspberry Pi as I have it set up right now. And as you can see, I have those pins hooked up. The resistor is soldered in and it's covered there with electrical tape. And this is all we'll need as far as physical setup for this project. Okay, and I'm SSH'd into my Raspberry Pi now, and the first thing I need to do is add one-wire support. I'll do that by opening up /boot/config.txt. And now that we've scrolled down to the bottom of the file, we'll add the following line. And then we'll close and save the file. And now we'll need to reboot the Pi. And now that we've rebooted, we're going to add a couple of kernel modules. And now let's go find the device on the file system. And here we're going to cd into the /sys/bus/w1/devices directory. And now we'll do a listing of that directory. Now what we're looking for is 28-something. That's the serial number of the device. And as you can see from my listing, I do have that device showing here. So now we'll go into that folder. And now we'll open up a file to see what it's reading. Now pay close attention to this output. Where it says yes, that means that we've had a successful read. And now we see the T equals 21,000. That's going to be our actual temperature. Now that we know our sensor is working, let's create a Python program that will show us some more useful output. Now there's a lot of code here, and if you want, you can just grab the script from our repo here. And I'll take you step by step through this code. Now the first part here, we've imported the OS, glob, and time libraries. Next, we make a couple system calls to modprobe. Now we did this earlier when we were testing out the sensor, but we're putting it here in the script so that it runs every time this script is run. We've set our base directory for the devices. We have the device folder and the device file specified in these variables. Now the function we're going to use here is called readTemp_raw. And what this does is it opens up the device file and it just reads the lines into a string array and then closes it. Now the readTemp function is a little bit bigger, and as you can see, it calls back to readTemp_raw, and then it's going to parse through those lines and it's going to spit out the temperature into a string. And it will show us the temperature in Celsius and Fahrenheit. As you can see, the temp_c is a Celsius, and what it does is it takes a temp string, casts it into a float, divides it by 1,000. Earlier, when we were doing the test, you noticed it was at 21,000. That's actually 21.0 Celsius. That's why we're doing the divide by 1,000 here. And then temp_f is a Fahrenheit conversion, so we're just taking that Celsius temperature and converting it to Fahrenheit. And then we're going to return both of those values out of this function. And as you can see here, we have while true, print readTemp. And so every second, it's going to read that temperature. Let's go ahead and run this script and see what it does. Now I'm running this with sudo python gettemp.py. And as you can see from our output, we've got 21 degrees Celsius and 69.8 degrees Fahrenheit. And every second, it's going to continually run this. So congratulations, you've written a script to read this. There are many things we can do with these values, including sending them up to the internet, logging them locally on the device, or writing them to a file. So let's go ahead and see how to write it to a file. And that's actually fairly easy. Type in the following command. And what this does is it runs gettemp.py and then it appends the output into a temp file. We'll let it run a few seconds so it gathers some data. And if we take a look, there's our text file full of our values. But how about if you want to do something like comma separated values? That's actually fairly easy as well. Let's go back into that Python script. Now as you can see here, I changed our output a little bit, and I'll explain this. Now the str function, what that does is it creates a string, and anything you pass into that str will come out as a string. So since these are both float values, we want to convert them to a string. That way we can concatenate the string, and then the string is what will be output. So in here, I've taken and created the result. The result variable equals read temp. So that means the output from read temp goes into result into an array. And so I print result 0 and then cast that to a string. Then add it to a comma, and then I add result 1, pass that through a string, and add a comma at the end of that as well. So if we've done everything right, this should print out the two values separated by commas in a line, which is also known as CSV. And so now I'll run that Python script. And as you can see here, we're getting our comma-separated output. You can use this to make comma-separated files. Now we pipe this into test CSV. And as you can see, we have the values that we're looking for written into the file. This is how easy it is to work with this sensor. So basically, like everything in Unix, it's just a file, and we're reading that file, and every time we read the file, we're taking those values and outputting them with this script. Now we're going to do something kind of neat here. What I'm going to do is I'm going to run this script that's continually reading the temperature, and I'm going to grab that temperature probe, and let's see if the temperature goes up as I do that. Now as you can see, it was a little slow to go up, but it did start going up as I held on to it. That's just kind of a neat trick that you can test the fluctuation of heat in your temperature sensor. In this module, I showed you how to wire up a DS18B20. We added one wire support and then rebooted the Pi. I showed you how to find the device on the file system, and then we created a Python script to read and display temperature. And this is just the beginning of what you can do with this sensor. There are a ton of different projects you can do with a waterproof sensor, including weather projects, testing fluids, things like that. There's all kinds of interesting stuff you can do. And due to the simplicity of this script, you could use this script to send that data to the internet, or send it to a file, as I showed you, send it to your Google spreadsheet, send it anywhere you want. Very simple and very easy. Python is definitely a huge tool to have in your toolbox, and we showed here how useful and versatile it is. And now, on to the next module.